Hello students, welcome back to JCE Connect series of lectures. As we were discussing about equation of motion, uh, as I said uh, in dynamics of fluid flow, so that is the study of motion of fluid flow along with the force causing the flow. So for the analysis of fluid motion, so we are using Newton's second law of motion, the very famous and very familiar equation, and here we are utilizing that equation for the analysis of fluid motion. That is the net force Fx acting on the fluid element in the direction of x is equal to the mass m of the fluid element multiplied by the acceleration, that is ax in the x direction. Thus mathematically we can write Newton's second law, that is Fx equal to m into a, that is m into ax. So here I written as a x means you are applying a force in x direction. In that direction only the fluid element acceleration get changes. So if you are applying in y direction, you can write in m into ay. In z direction, fz will be m into az. So the various forces which are being considered for the fluid motion are, they are present also. They are gravity forces, and the pressure forces, viscous forces, that is due to viscosity, the turbulent force, that is due to turbulence, and compression due to compressibility. Okay, so these are various forces which cause the fluid motion. Okay, so these are the forces which cause the fluid motion. So if these all present for the motion of the fluid, then the above equation can be written as the net equation becomes Fx will be what? Fg plus Fp plus Fv plus Ft plus Fc. So the sum of all the forces which are making the fluid to move. So these all are responsible for the motion of fluid. Hence, so we are taking the sum of all the forces here. Since the force acting in x direction, hence it is been written in x direction, that is Fgx, Fpx, Fvx and Ftx and Fcx. So these all will be acting in x direction, hence it is been written in x. And if you suppose if you are applying in a y direction, so if you draw like this, this is y and this is x. So y and this is x and this is z. Okay, so if suppose it is acting in a z direction, can write in fz equal to fgz, fpz, fvz and ftz and fcz. Okay, so this is the net force what we are getting after applying the force on the fluid. So it means what? These all are responsible for the motion of the fluid. So later, so this is the net force acting on the fluid motion. Later various researchers, various scientists studied the dynamics of fluid flow, and they are analyzed the fluid motion, and finally they have obtained the equation, and some have considered some forces and some have neglected the forces, and finally they have obtained their own equation and they have analyzed the fluid motion. So here one researcher has studied about the fluid motion and he has analyzed, and he neglected the compressibility of the that is compressibility force. Here if the force due to compressibility Fc is negligible, means he has considered the fluid as incompressible. So as incompressible, the density will be remain same. If you are considering means if you are assuming the density of the fluid is keep on changing, means it is a compressible fluid. So that is possible only in case of a gases and all. Okay, so since we are studying incompressible fluid, hence the density remains same, hence the compressibility force is neglected here. Then the net force acting on the fluid motion are gravity force, pressure force, viscosity force, and so these all forces he has considered, and he analyzed the fluid motion, and this equation is known as Reynolds equation of motion. And one more scientist, he also studied the fluid motion, and he neglected the turbulence. And he has obtained the equation and considering only three forces: gravity, pressure, and viscous, and this equation is known as a Navier-Stokes equation. And one more comes, that is he considered the fluid as ideal, means it doesn't have any viscosity. Since viscosity is zero, hence viscous forces will not be present, hence the resulting equation is known as Euler's equation of motion, and Euler has considered only the two forces, that is gravity and pressure. So this is very important for our study in this particular chapter, that is Euler's equation of motion. Here this is very important. Considering this equation, the Euler has derived the equation for a streamline. You know what we mean by the streamline flow, and he derived one equation that is called as a Euler's equation of fluid motion. And later the one more scientist, that is Bernoulli, he utilized the equation of Euler and he derived an equation. That equation is known as Bernoulli's equation of fluid motion, that is usually called as a energy equation for the fluid. And we'll discuss later in detail about the Bernoulli and as well as the Euler's equation. So I hope you understood about this one. Okay, next. So the energy possessed by the fluid means whenever the fluid starts flowing, so what are the energies it possesses? So the energy means, as we know, in general it may be defined as the capacity to do work. Energy means what? The capacity to do work. So what are those energies this fluid can possess? So though the energy exists in many forms, there are so many types of energies, at the following are important energies for the fluid motion. So what are those? So they are potential energy, kinetic energy, and the pressure energy. So these three energies the fluid will be possessing. And as we know, the potential energy the fluid will gain because of its position. The kinetic energy the fluid gains because of the motion, it gains the kinetic energy. And because of the pressure whatever we apply, and because of that it gains the pressure energy. So usually these three kinds of energies the fluid will be having in its motion. Okay, so we'll study about these energies, and we'll get the equation also for this that is called as a Bernoulli's equation of fluid motion. So we'll study in detail about this one. Next. So Euler's equation of motion, as I said, so we'll be studying in detail in the next class along a streamline. And Bernoulli's equation for the fluid motion means Bernoulli has utilized this Euler equation, and he obtained one equation that is called as a Bernoulli's equation of fluid motion. Again, in a fluid, the Bernoulli has applied the equation for first he has applied for a ideal fluid, and second is a real fluid. The ideal fluid is one which doesn't have any viscosity, and the real fluid is one which has viscosity. So for both the fluids, what the equation may get changes, we'll study about this one. And what are the assumptions made for deriving the Bernoulli's equation, and what are the limitations of this Bernoulli's equation, we'll study in detail in the next session. So these things are very, very important in this particular chapter, that is dynamics of fluid flow. So you all, I hope you understood the ideal fluid and the real fluid. I'll repeat, ideal fluid means the one which has which doesn't have any viscosity, and the real fluid means which has a viscosity. And what is the change in the equation we get in Bernoulli, we'll study about that in later part of the chapter. Okay, thank you all. So we'll continue next class.